negative. Now, another one is the pentadienyl. So really similar to that allele. Okay, just adding on a little bit more there. So same kind of deal. You can either have just A to 1. You can have it down through here and one of the pi bonds. That would be an A to 3. Or there, there, and there. So A to 5. So you have quite a few situations here. I'm not going to draw them all out. They're all available, and you can picture or try drawing those out actually if you like. What can happen with this guy is that it becomes part of a cycle. This becomes metallobenzene, where one of the carbons is just replaced. Probably aromatic with all these delocalized electrons that are located there. Okay. Now, cyclopentadienyl. We'll talk about this one, but now we're going to see it in a little more detail. This is CP, that one that we've shown before. Okay, where you have a negative site on that carbon. So this can really instead be expressed like that, where you really have delocalization. So picture you have this negative site here and these two pi bonds there. So you can have anywhere between A to 1, A to 3, and A to 5, just like we saw for the pentadienyl. Now, in terms of the amount of electrons that are being donated, so this would just be an X ligand. This would be XL, and then XL2. So 2 electrons, 4 electrons, and 6 electrons. In that case. And you can kind of picture how that might look. Well, easiest one would be A to 1. Or just look something like that. There's our A to 1 CP. A to 3, you're going to have to actually draw it out, where now you have delocalization over 3 of them. Okay, just like that. That would be A to 3. And then A to 5 is really where it sits, directly on top of a metal. There's your A to 5. Now, looking at, go to screenshot here. Okay. Just going to look at the molecular orbitals of CP, and really just the delocalized ring is what we're looking at. So here you can see there are 5. So 3 filled, and then there's your antibonding. So you can see which metals might bind, right? You can have sigma from these, a nice E1 orbital to metal BZ squared. And then you can see how you can have pi as well with the other DXZ or DYZ, making pi bonds to your metal. And then you can try and picture up here how you might have pi or delta back bonding again. Now this bottom picture is for a metallocene. So a metallocene, here, I don't know if you can see it on there. It's a sandwich, and we did kind of talk about them. Like ferrocene. Okay, so it's 2 CPs on top, one bottom of a metal. And this picture that you're seeing here is showing, kind of hard to see, so it's way too clustered. This would be 1 CP, metal, the other CP. So just right here would be 1, okay? Let's see if I can draw that out. I'm not sure I can, let's try it out. Because it is kind of hard to see. There's just one case showing one bonding opportunity. This is showing you again, you can have a really similar thing. So this is just showing you with the 4s. In this case here, it's using the dz squared. So same thing, this is still a sigma bond. And then you can see how this changes now to the pi bonds. And you can go through each of these in detail. But we're not going to do that right now. Now let's also look at the full, oh, I guess I have to get out of this. Let's look at the full molecular orbital picture. Uh-oh. Okay, I don't know how to get rid of that line right now. Let's see. Clear. There. Okay. And close it. So here you have on this side your 2 CP rings. So everything's doubled because it's all degenerate. Okay. That's showing you the molecular orbitals you have for those. And on this side, you have your metal atoms, so iron. And then what happens when those guys mix to make this big, massive molecular orbitals in the middle? Ones we're focused on are really those metal-centered ones right there, showing you your HOMO and your LUMO. Okay? And we really don't have to get too much into that, but I just wanted you guys to kind of see how complicated it can get and just really what's involved here. Okay? And you could do, even if you really wanted to, you can find the symmetry of this guy and figure out all the different symmetry labels here. But let's take it a little bit farther. So we're going to stop here for now because I was keeping this trying to keep it in bite-sized pieces. This was the end of the metal carbon ligands that we're talking about. And then the next video will have a couple of the other ligands on there. So I'll be back soon.